Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 11 maths, algebra, nature of roots. And we've actually come to the last section in algebra, grade 11. So we just have a look at that very quickly. We can see that we've covered all of these aspects, and then the last aspect here is just basically nature of roots. Now when looking at the section nature of roots, we have to understand the following: that everything is based on the discriminant delta, which is b squared minus 4ac. Where does delta come from? It comes from the quadratic equation, which is x equals to minus b plus minus the square root of b squared minus 4ac all over 2a. And as you can see, that delta is underneath the square root sign, which tells us a lot about our nature of our roots. For example, if delta is equal to 0, we're going to get equal roots. And if delta is less than 0, we're going to get non-real roots. If delta is greater than equal to 0, our roots are going to be real. And if delta is a perfect square, then our roots are going to be rational. And if delta is not a perfect square, then our roots are going to be irrational. So the first step is to learn what the discriminant must be for each one of the nature of the roots. Basically what I've just mentioned now, and I will mention it again as we answer more questions. So let's go and identify a few questions. November 2019, paper 1. Let's see what question came out on nature of roots. It says, discuss the nature of the roots of the equation 2 into x minus 3 all squared plus 2 equals to 0. Discuss the nature of the roots of the equation 2 into x minus 3 all squared plus 2 equals to 0. So for 1.3, in order for us to be able to do this, we need to, let's write down the question. 2 into x minus 3 all squared plus 2 equals to 0. Therefore, 2 into x minus 3 all squared equals to minus 2. And here now, if we divide both sides by 2, we're going to get x minus 3 all squared equals to negative 1. Therefore, if we have to look at finding the square root of both sides, remember that we're going to get the square root of a negative number. And the square root of the negative number means that the roots are going to be non-real. So therefore, we can say that the roots will be non-real. Why? Because remember that delta will be less than 0 for non-real roots. And as you can see here, we have minus 1. So therefore, our roots in this particular question will be non-real roots. Now, the other way that you could have looked at this particular question will be, if you want to open up the brackets, you can say 2 into x squared minus 6x plus 9 plus 2 equals to 0, 2x squared minus 12x plus 18 plus 2 equals to 0. And if you look at that now, if you write it in the standard form, 2x squared minus 12x, and here you got plus 20 equals to 0. And then now if you want to describe the nature of the roots or discuss the nature of the roots, we'll look at delta, which is the discriminant delta equals to b squared minus 4a. And let's work out what delta will equals to. So that will be b squared, which is minus 12 squared minus 4 times a is 2, there's a, and then c is positive 20. And if we now have to look at that, we can actually just put that in our calculator and see what we get. So let's see. Let's say minus 12 squared minus 4 times 2 and times 20 equals to, we should get a negative value, see, minus 16. So therefore delta is negative, so it's minus 16. Delta is equal to minus 16. Therefore non-real roots, because your discriminant is less than 0. Right, so that's the alternative approach that you could have had to this particular question. Let's look at the next question. November 2018. Let's see what came out under nature of roots. So nature of roots here will be 1.3. The roots of the equation f of x equals to 0. It is solving the roots for us here. Remember that the roots are the x-intercepts here of our quadratic equation. So they're saying determine the values of m for which the roots will be non-real. Let's try that again. The roots will be non-real. So remember now, for non-real roots, delta must be less than 0. So our discriminant is underneath the square root sign, which will be b squared minus 4ac. So all you need to do is take whatever's underneath the square root sign, and we have to now let it be less than 0 and solve for m in this particular instance. Let's do that. So we got 16 minus 4m into minus m plus 5 must be less than 0. Delta must be less than 0 for non-real roots. So let's go work that out. So here we got 16 minus 4m times m is plus 4m squared. So minus 20m divided by 4 will give us minus 5m, and 16 divided by 4 is plus 4, and that will be less than 0. So now we have a quadratic inequality, and if you look at the previous videos on how we go about solving quadratic inequalities, this is exactly what I'm going to do in this particular question. So I'm going to be solving this quadratic inequality. So once again, learners, don't forget, double check the opening of your brackets and check your algebra here. See, like for example, plus 4m squared, and we have minus 20m, and so on. Writing in the standard form of the quadratic equation is important as well here. So let's now factorize this. Now remember the steps for solving a quadratic inequality. Okay, we have to factorize first. So m times m is m squared, and here factors of 4 were multiplied together to give us positive 4, when added together to give us negative 5. That will be minus 1 and minus 4. Therefore, my critical values here will be m equals to 1 and m equals to 4. So positive 1 and positive 4 are my CVs, or critical values. Therefore, now I will draw the line, put my CVs in order, 1 and 4. If I substitute a value greater than 4, which will be 5, into this, I would get now m, which is 5 minus 1 is 4, so that will be a positive, times 5 minus 4 is 1. That's also going to be a positive, which will equals to a positive. So therefore I have positive here, negative, and positive. So where will it be less than 0? Less than 0 will be here. So therefore my answer will be m greater than 1 and less than 4. And that's my solution. M must be greater than 1 and less than 4. Learners, if you haven't subscribed already, subscribe to JL Maths. Like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.